Hello everyone and welcome to this webinar. Let's wait a couple of minutes to let the people join. In the meantime, looking forward, the next webinar is going to be the 2nd of July, and it's going to be a live session with a current client, which is SolarEdge, discussing different situations, trends in the market, and so on. After this session, for sure, you're going to be receiving this recording and documents. So feel free to receive the email, and there you will have everything listed. So let's wait a couple of minutes, and then we can get started. Okay, so I guess we can get started. We have left like a couple of minutes, but yeah, let's get started. So hello everyone again, and welcome to this webinar. Today we're going to be navigating through the slope terrain in utility scale PV projects. And for that, we are going to be assessing what's the type of resolution in topography needed for each phase, starting from the decision-making process and regarding whether a plot of land is suitable or not in terms of slopes and other limitations. So today I will be presenting the webinar on my own. My name is Jorge Contreras, and I am part of the RatedPower technical team. As my background, I'm an industrial engineer specialized in renewable energies, specifically in solar energy, as a solar engineer and developer. As a technical advisor for Iberia, I'm mainly focused on customer success, being a technical bridge between end users and product, and therefore ensuring that our clients get the most out of our software, our tool, RatedPower. So before starting, I would like to mention that meanwhile we are doing this webinar, Intersolar Europe event is taking place in Munich. And this is a 3 days exhibition and network event. So where the main solar industry players present the different trends, new products, and upcoming challenges. So feel free to pass by because we have a stand over there. We are at booth 84330. And for sure, if we want to see the software in person, you want a personalized demo, and also you just want to know what's the new initiatives up to come, feel free to pass by, okay? Okay. So for today's session, we are going to be starting with an intro of our topographical calculation model. We are going to understand the topography resolutions needed on each phase of the PV project. We are also going to explore some different topography datasets available on the market and how to use them in order to enhance our project precision and efficiency. We are going to be determining the suitability of a complex terrain in a real PV project. And finally, we are going to end up with a Q&A session. So should you have any question throughout this presentation, feel free to drop them down in the question box down below, and go to webinar question box, and we are going to try to reply them. Okay, so for those who don't know what is RatedPower is a software to quickly optimize and streamline the design and engineering process of a utility scale ground-mounted PV plant. So one of the main aspects to consider when it comes to PV plant optimization is not only the technical issues, but also the topography. When I say topography, I'm referring to a structure installation, terrain slopes, undulation, pile lengths, possible earthworks, and so on. So regarding the topographical calculation model that we are currently using in the software, it relies on 3 digital elevation models, and it starts from a cloud of X, Y, Z points, and it converts them into a surface. So the very beginning one, at the origin of the software, it was the inverse distance weighting, which is currently used only for overhead lines. And why it's only for overhead lines right now? Because it has kind of an issue regarding the what is known bull's eye effect. As you can see, the surface is kind of spotted and not pretty well defined. So in order to correct that, we developed another algorithm to smoother the surface, and by using an API key from Google Earth. By using this surface with the default Google Earth data, we can improve the resolution of the surface, and so we get much more accuracy. Specifically, this Google Earth data by default is 30 by 30 meters, but it's more than enough for a pre-feasibility study. Then after that, we also provide the user to upload a custom topography data. And for this custom topography data, we enable a third algorithm, which is a triangular irregular network. And we decided to develop this algorithm because it perfectly fits and adapts to the accurate data coming from contour lines or even raster images. And well, transforming these contour lines into a cloud of points, this cloud of points in a triangular irregular network, and then after that, a perfectly defined surface. So once we have the digital elevation model available at RatedPower, the surface is automatically parameterized into a grid regarding the different north-south and east-west directions and slopes. So with this grid, we could start lately inputting the different topographical restrictions for structure installation. For example, if any structure surpasses any of the limits that we enable, as we can see in the video, for example, this is a structure north-south limitation of 10%. In any of the north, south, east, west, or even terrain undulation limitation that we have given, the software will automatically remove them. So these default values that we automatically get on every single field that you can see in the video comes from the manufacturer, the structure manufacturer. However, we understand that the user can perform a much more conservative analysis, and so you can change it in order to see how the surface is defined. Again, if you want to go for a earthwork solution because you don't want to stay not only in the structural limitation but also install them with under earthwork conditions, users can optionally give this limitation, and this limitation is regarding how much over 70% of slope you want to place a structure under cut and fill earthworks and volumes. So as you can see in the video, whenever you define these values and then you run the simulation, for all structures among lower and upper limits, RatedPower will try to group them into different surrounding platforms and then create a kind of a boundary to define what's the capability of the software to place those structures, and so achieve the defined capacity of the user. Okay. So if you want to go and dive deeper into these calculation models, how does it work, and so on, feel free to have a look of all of these additional resources. You have the topography analysis methodology. You also have knowledge-based articles, and specifically you have a guide for users if you are interested on how to convert and upload a raster image into RatedPower. And also feel free to watch previous webinars regarding this topic or some others, and stay tuned for different RatedPower coffees, which is kind of a 15-minute session briefly explaining different topics, and there is one regarding exactly this topic. So for sure, you will be receiving these additional resources via email after this webinar. So topography resolution on each phase. Determining what's the optimal topography resolution on each project stage is a key factor, not only for time, but also for money. So I researched a little bit about previous year, specifically 2023, and out of the 26,589 projects that customer developed in RatedPower, they had performed slope analysis. So among those projects, almost 93% of them had uploaded, had used default Google Earth data topography. But on the other hand, only the 7% had used custom topography. So this gives us valuable information because among those 7%, it turned that if we carry out on a slope frequency histogram analysis, the most repetitive values in terms of north-south, east-west slopes were around like 8% and 9% onwards. So if we take all this data and we calculate the mean standard deviation for north-south and east-west slopes, we finally got that the mean slopes were around 10.5, 10.8% respectively. So if we have this information in mind, if we go and move on every single stage on the project development, for a very beginning site identification, we can quickly design in several locations, and we just want to estimate the amount of installed capacity the project might have. But in that specific case, with Google Earth is more than enough. You don't need to overkill with super dense resolution. However, if you go on with the second stage with a pre-feasibility study, where you want to have like a cost-benefit analysis, the different technical options may have, you just need to compare the cost to build estimation. And for that, again, Google Earth is more than enough if the terrain is pretty much plain. But as we previously mentioned, if you have significant slopes exceeding 8, maybe 9% of north-south, even east-west, maybe it's recommended to compare them between default and custom in order to see what's the technical difference, for example, in the bill of quantities, the number of structures, the number of inverters, even the distances with the fences and so on. If we move on with the project finance, where you want to develop a feasibility assessment, in this case, what you are looking for is for an economical preferred option. And the goal is to have comprehensive information to start the preliminary process, the permitting process, for example. So if the terrain is pretty much plain, you can go with the Google Earth because so far the grid resolution is not that bad, it's 30 by 30. But so you want to include the terrain slopes in earthwork calculations, the financial assessment, and if you want to have a really good accurate topography, for sure, you're going to need to include them in your calculation and also in the project finance. And for this purpose, you will have to upload a digital elevation model. Then for a fourth stage, for the financings and contracts, doing the technical due diligence to make the project look as close as possible to the reality. For example, signing contracts, defining suppliers, final layout. For sure, you're going to need a topography, a custom topography provider. For instance, you could go for a survey, topographical survey, or even external providers, as I am showing right now. For example, here in Spain, you have IGN, the Spanish IGN, or even in France, you have the RGE, which is the French IGN. And then finally, when you are inside of this, the scope of RatedPower, aiming to monitor and go for the detailed design, you just want to confirm the results, and you just want to follow the project implementation as much as possible. So nowadays, it's commonly used a 3D digital twin. So far, what I would suggest is it's not only important to have this digital elevation model, but also connected with the other elements like being AutoCAD designer in order to have everything tracked. So what's the topography database available on the market? So first of all, by default, Google Earth is the one used at RatedPower. In particular, RatedPower uses SRTM, which is the Shuttle Radar Topography Mission. And this mission, well, it covers 1 arc-second, which is approximately 30 by 30 meters, as I mentioned, and it's covering the 80% of Earth's land. And you have to be aware of that, because sometimes if you are developing projects for latitudes higher than 60 degrees north, for example, Norway, Sweden, even Finland, or even Canada, you could encounter a lack of data. So in that case, if you are suffering from this issue, please, you could either upload your own topography if you have the provider, or if don't, please do not hesitate to contact us to support, because we are here to support you and to help you out in this issue. Okay? However, if we are talking about custom topography data, and we look back to the previous results that we shown, out of these 7% of projects that had uploaded custom topography, which is more or less 1,911 projects, we get super valuable information about what are the 8 main countries which had uploaded external digital elevation model in terms of north-south and east-west. And by using this information, we have researched a little bit about different and usable digital elevation model providers for those countries. For sure, you are going to be receiving this information, because we are going to share it through email at the end of this webinar. But in general terms, as you can see in this data table, we have all of them are public or even open source. Some of them need user registration, so some others don't, but at the end, you have diverse digital elevation model coverage, like globally, country-like, even regionally, different formats, and also various grid resolutions, starting from 1 meter up to maybe each resolution you want. So if you are wondering what's happening with the rest of the world or even other countries, here you can find some other useful data sources. If you are talking about global data sources, you have Open Topography, which is super useful if you are mostly focused on developing projects in the United States, although it also has worldwide data. And their solutions are pretty well. They start from 1 meter upwards. The only thing to bear in mind is that some of the different databases that you can see on the right side are limited access. So for sure, you're going to need a license. But on the other hand, you could have even for United States, Europe, etc. And an additional Earth data provider is NASA webpage, which gather worldwide information, specifically in topography. And they have various resolutions, and it solved the problem, as I previously mentioned, regarding the SRTM, because right now with this database, it covers almost 99% of Earth's landmass. The only problem, well, it's not a problem, but you need user registration, and the process is quite long. You need to wait a few days. Then, if you are asking what's going on in Europe, you have two providers. For example, Copernicus system, which is a service provided by the European Space Agency. This is a worldwide web page, and by using different satellite images coming from Sentinel-2 and Sentinel-3 satellite missions, you can get terrain images from 1 to 30 meters. The only problem, the information that you can download is super heavy, and then you have to filter quite well. Otherwise, you will have super heavy files, and you will need to treat them before uploading them into the software, or even working with them. And finally, this is not a map view, but it's a data browser, and I find it super useful if you happen to be developing projects here in Europe. And this is the European data browser. Why? Because this is a browser for the European Union countries, and it connects every public European database regarding different matters. And one of the matters is topography. So if you search by digital terrain model, as I'm doing right now, and you filter and look for a specific country, you will notice that you will have different elements. For example, here I had the Czech Republic, but also for Belgium, what country you need, and it's totally public. For sure, if you think there is any other useful data resource that we are missing, you have the chat box down below in the GoToWebinar. So feel free to drop your data source down in this chat box, and we strongly value this feedback and your insight regarding this topic. So terrain assessment. Let's move to the software. So first of all, I would like to mention we are gonna be doing different scenarios comparing between Google Earth, which is the default one, versus custom one, which I'm using the Spanish IGN. So we are gonna be doing the exercise with the 3D scheme that the software provides, the north-south analysis, only north-facing structure, and also for terrain undulation. So let's go back to the software, and we will see what's going on. Okay. Okay, so as a quick overview, I guess you are watching the software right now. This is the main menu, and this is the side menu with the different tabs. Just to understand a little bit, RatedPower takes the projects as a folder, and inside every folder you have the possibility to develop as many designs as possible. So if I go to, sorry, let me switch back to a different account. Okay. Okay. I have to switch because this is a cloud-based software, and that's why I have to switch between one account and another. And where I have stored my project is, okay, it's this one in this account. Okay, so as I was saying, this is the main menu where you have everything stored, and the side menu you have the project folder. Inside the project folder, you have different projects, and if you consider a project as a folder, you will have stored in every of them the different designs that you have been running, and you have a limited option to optimize those designs. If I go to this project, which is the one that I will be using for this webinar, we can see the different exercises that we are going to be comparing for this webinar. So the first one are these first and second designs. So let me navigate to the software and the interactive site creator and design process in order to see how to assess the different exercises. So this is the design process. From left to right, you have the different tabs in order to configure your PV plant while it's uploading, updating the data. And then on the right side, you have the main peak power parameters, energy, financial, substations, and history of designs. So for the first thing, I would like to mention the software. The first thing that needs is always a site. I have already created this site. Actually, I'm gonna edit this site in order to see what's the initial input that we need to give the software to understand the site we want to assess. Here we have the different elements that we have been adding through cat import. Not cat import, but you could even upload shapefiles, different KML, KMSet elements, and with a proper naming, you can get, like in this example, 3 interconnection facilities, 3 levels, different parcels, and different restricted areas. As you may guess, this is a hybridized plant, and those are the shadows of the eolics. So in terms of satellite images, I decided to take this specific site because of the configuration, and well, it technically is difficult because of the mountain, and that's why I decided to place my PV plant here. So after defining the site, let me go back to the design process. You automatically get the topography data from Google Earth, as I mentioned, because it's connected through an API. However, for this exercise, I performed for this design, as you can see down below in the right side, we performed this analysis with Google Earth and also with IGN, which is the custom topography that I uploaded. If I press show details, you will see that grid that I mentioned regarding the topography elevation model. So comparing these two elements, we see that we have run different designs, one for Google Earth and one for IGN, and we cannot see the difference between peak power and nominal power and DC-AC ratio. Why? Because only for the 3D scene, if we go and compare the 3D scene, we will notice that the 3D scene coming from Google Earth is much more smoother and not that accurate comparing with the IGN, although it's quite significant and well, but it's not that precise. If I switch back to the second one, which was with the topography coming from the IGN, we will see that the 3D map is going to improve in resolution because it was a 2 by 2 meters grid. Okay, so for the first analysis, you can see here different paths, different roads, also the river, different elevation and small hills. So comparing both designs in terms of peak power, if we go back to the project folder, we could either carry out this analysis and compare them, and we will notice that both of them are exactly the same. Why? Because although we have uploaded the topography, we haven't still defined the restriction considering the topo elevation model. So that's why you are having the 3D elevation model, but not applying earthworks. So let's move back to the slides, and then let's go for the second analysis, which is applying north-south slope direction limitations. So for doing that, you just need to go to topography tab, and then by enabling removing structures and applying north-south analysis, we can get the same values for the limitation of the slopes in both north and south directions. And this value is coming from the manufacturer. However, I can change the value and then run a simulation. So this is exactly what I did in this, on the right side, on these third and fourth simulations. I just evaluated was the final layout removing those structures exceeding the 10% of slope in north-south direction by using, the first one is using Google Earth, and then the second one is using IGN. So the first impression we get is by using Google Earth, we get, let me switch back to the third one, we get much more, less power, sorry, which is 114 megawatts peak, than using the IGN, which is the custom topography data. Specifically, we get 1.67% less peak power than the custom topography. So this is why we have more granular structure adaptations. Then we have a much more realistic terrain. And if we go to the 3D scene, you will notice that yeah, the terrain in some specific spots with different and small, let's say, depressions, small rocks, and so on. Those structures have been removed, but in north-south direction. So I would say that for this analysis, for north-south, I don't think it's worthy to have a much more realistic, because although it's much more granular, it still doesn't make the difference in terms of north-south. So let's switch back to the presentation, and then let's see the third strategy, which is only north-facing structure, in order to identify those structures facing to the north, which is going to be super hard to take the sun rays. So for doing that, you see here in the left side that we are doing the north-south analysis, but only for same values for both slopes. We could either go for a different analysis and differentiate north and south facing slopes. And for doing that, we can disable south facing and only focusing on north facing structures, being conservative. So this is practically what we did here with the 7th and 8th design. Indeed, the 7th design is only for north direction, applying 5% in order to be super conservative. And if I go with a custom topography, exactly with the same parameters, you will see that that the site it barely changed, and also the peak power is practically the same between one and the other. If I switch back, it's going to be super similar. So in this third analysis, we have almost no differences. So having a better resolution is not worthy, because for this sort of analysis, only for north-south or even just north, we are not considering the grid resolution. I mean, we are considering, but the terrain depends on all the factors. So in my opinion, I would say that I wouldn't upload a super high quality grid if I'm planning to do north-south or even south east-west direction. So if we move on with the fourth exercise and scenario with the terrain undulation, and this is where we're uploading a super accurate topographical data elevation model comes to play, because by applying a terrain undulation, which is the third option, we are telling the software that we want to give a pile length tolerance for the structure to be placed. So for instance, if every pile of one structure is 3 meters, we are giving this tolerance of 1 more meter or even 1 less meter to adapt to the terrain. So if we comply this exercise, here we have it listed, design number 10 and design number 11. One is with Google Earth data, and the other is with custom topography data. So if I go to the Google Earth data applying this analysis, we will see that the surface is super smooth. Let's wait for uploading. Yeah, okay. It's updating. Okay, finally. So although the surface is super smooth, and because of that, we don't get to see all terrain depressions. Actually, if we go to the 3D map, as we previously did, those terrain depressions that we could see in the previous designs, if you notice, had been removed, but not in such a good way. I mean, this is not super precise and accurate. So if I use the topographical from IGN, we are going to notice that the number of structures to be removed has increased considerably. And this is because the grid that we have been using has improved in accuracy and in resolution. So if I go again to the 3D map, by using the IGN topography, you will see that in those spots that you had kind of different depressions, different rocks, etc. Now you have structures removed because of the limitation of the tolerance. So for that, I would say that uploading a much more realistic surface, we can we get to see what's the imperfection of the terrain, and so if we compare the results, specifically the peak power, let me switch back again in order to do a proper comparison for the terrain undulance and IGN. If I compare both of them, we can see that for the custom topography, we increase the peak power. We decrease the peak power. We get less peak power, specifically 3.68% less than the Google Earth data. So this is super interesting because if you are doing a topography assessment, for sure it's going to be a key factor to study the project topography and the different slopes and the different, specifically, depressions of the terrain. So maybe if you are using an accurate digital elevation model on a very early stage for north-south, east-west direction analysis, it's not pretty convenient to have spend so much time getting a digital elevation model because you are not going to notice in the north-south, east-west direction. However, if you are using a really accurate digital elevation model, it's strongly recommended if you want to fully adapt your structures to the to follow the terrain and so the imperfections that it may have. So this could be like the specific case and the specific case of use for the digital elevation model. However, if we would like to perform this analysis super precisely and including every single restriction, not only for terrain undulation, but also north-south and east-west, you see that we can run this analysis all together and see what's the result that the software is offering. In the meantime, we can also correct some of these specific cases with structure removed because of tolerance of undulation in the terrain by applying earthworks, as we did with the structure limitations. So for instance, we can give like a specific value, like a threshold between all structures will be placed between 1 meter and 1.5 meters. And you will see that the software is going to create kind of platforms and group them together in order to place those structures that are complying those two values, the upper and the lowest value. Okay, so the previous design altogether has already loaded. And this time when loading the project is because I haven't mentioned that, but while you are running a simulation, you automatically get the documentation updated. So not only the documents, but also the spreadsheets, the drawings, the AutoCAD layout, the layout 3D, also the single line diagrams, etc. So for example, for this last one with the platforms from 1 meter to 1.5 meters, we're having these documents already loaded. Okay, so this is pretty much all. Sorry, I missed. This is pretty much all. So let's move with the Q&A session. And for doing that, please use the question box in order to, well, we can answer that questions, and we will see if we can answer all of them. Okay, so questions. Perfect. So the first one is, how can I know how my terrain looks like after applying earthworks? Okay, so it's exactly what I mentioned. If we go back to the software again, by downloading the documents, one of the documents is the layout 3D, which is actually this 3D map that we have been watching right now during this webinar. But also you have the topography analysis terrain slopes. So whenever you download, for example, this editable AutoCAD file, let me download it, you will see that you have all the layers available in terms of the grid resolution, the different structure placement, the ones that have been removed, the others that have been applied with earthworks, and so on. And this is super useful because we have recently launched a new upgrade, which is right now you can also see the contour lines generated by the software when you upload a custom topography site. Yeah, exactly. So this is actually what you get and where you can find this information. Where you can get all this information in a layered document as AutoCAD, and then you can start working with them, with the new contour lines, with the earthworks applied, cut and fill, etc. Okay, next question. How can I know? No. Okay. What's the maximum topography file size that I can upload? So you have a limitation of 500 megabytes. So be sure that when you upload the topography, when creating the grid, try to trim your site alongside the site that you have defined along the parcels and the available areas. Otherwise, you will have a super heavy file and you won't be able to upload it. Okay. Next question. Okay, next question is Google Earth elevation data exactly the same as Earth's RTM 30 by 30 from 2000? Is the elevation data affected by the presence of forest, water, or bodies? Okay, this is a pretty good question. So far, what I have been researching is NASA has been, let's say, upgrading and creating new layers specifically for those latitudes upper from 60 degree north, and they have included different topography data for those spots. However, there are still some places over these latitudes that you might encounter some difficulties. But yeah, they are trying to upgrade this resolution, and one of these trials is this NASA web browser that I showed during the presentation. However, if you are interested on that, there is an article regarding what's the resolution of Google Earth data. Otherwise, you could go for a solution uploading your own topographical data. In terms of design, are custom topographies preferable than full topography studies on site? What I would say here is, normally when you are doing this kind of studies, you are in a very beginning stage, and you just want to have an idea what's the technical solution that you could have in a specific terrain. So in this case, for example, with my opinion, I would consider this site convenient, but maybe with some difficulties, specifically for trackers, for example, because here the terrain is not properly adapted for these trackers, and you have specifically for the custom topography data, some holes, some different depressions, and then you in the future might encounter some problems. However, you could use the software to assess those situations. And then, for example, I could go instead of a tracker for a fixed structure, a super short one. And you will see that in a very beginning stage, you quickly change the layout and you will have the new iteration and a new optimization. Will I be getting the recording of this session? Yeah, for sure. You are going to be getting the presentation after the webinar through the email, okay? What's the minimum resolution? Rated power assets for topography. So for topography, the minimum resolution accepted by rated power is, well, actually there is no minimum resolution, but I would say that the software is using as minimum the distance between pile and pile of a single structure. So imagine that you have between pile and pile 1 meter for the structure that you have selected. If you upload a grid, a digital elevation model with a higher resolution than 1 meter, for example, 0.5 meters, the software won't use this information. So the minimum distance will be 1 meter. So you won't add more precision to the calculation. So you have to be aware also what's the minimum distance between piles. But okay, so when doing earthworks, what points does it use for both tracker and fixed structures? So let's switch back to the software. Meanwhile, we can see, yeah. So right now, everything's updated. So far, we have a 3D model with a fixed structure. So for this question, if the slope of the terrain follows the axis of the structure, for example, if you are in a tracker solution, and then you are following the north-south direction, that means that it follows the axis of the tracker. So software will use every single pile beneath the structure. So we'll use every single pile as a point and we'll let them down in the surface as points. If the slope is perpendicular, so let's pretend that we have trackers. Again, let me switch back to the previous design and we will see that better. So if we have trackers, let's wait to load. Okay, nice. So if we have trackers and we are doing an east-west topography assessment, the points used for the tracker would be 14 different points around the edges of the structure. And it's going to be used if the analysis is perpendicular to the axis of the structure. Nice. So let me check if there is another. Okay. So if there is no other questions, thank you very much for your time. You will be receiving every single material shared during this presentation, and feel free to join on next webinars. Thank you. Bye.